Oh, g'day champions, we're finally back with that Studio 22 that I gave you part 1 on about 5 years ago. Not really, a couple of weeks ago. Now there's not a terribly graceful way of showing this board without completely disconnecting it. I've connected it up and gave it a quick test run, taken a few measurements now. As is the joy of working on Mesa Boogies, I've flipped the board back up to do some tweaks and some changes to the circuits. And I'll just show you that before we pop the board back in. There's a few values I might want to play with, so I've installed those components on the other side of the board. So we'll go over just the stuff I did, the restoration work and whatever, and the few modifications I did. Then we'll do some sound samples, and a fun little thing to do with this thing might be put a graphic EQ in the effects loop and see how close we can get it to sound like a Mark Series amp with a graphic on the front. And you can see down there the slots are there in the chassis for the EQ sliders, and the naked section of that board there is populated with the power supply area and the EQ circuitry for that. In amplifiers where that was an option, so they used the same board for the EQ and non-EQ versions, and this is a non-EQ. So starting from the input end in no particular order, there's lots of heat damage there on one of the low voltage supplies. You can see I've used some turrets there to basically recover that area. Power resistors or anywhere where there was completely destroyed traces, to get some mechanical support, I've just gone with some 2mm turrets. And that has the added advantage of lifting them off the board a little bit to allow some airflow and thermal isolation from the board to prevent it from getting any worse. Now, I've never seen these boards conduct, no matter how bad they get on the Mesa version amps. They can be literally blackened to a crisp, even delaminating in some areas, and they never seem to conduct even with the Mega. So I just use some conformal coat if it's that bad, just to seal it up again so it doesn't become hygroscopic, not hydroscopic, because that would make too much sense, right? Now that cap down there is silicon to the board. It may look like an odd choice to mount a radial cap like that, but the ulterior motive is that it gets it away from that heat radiating resistor. That 5-watt V-Shay wire wound there, I like those things because they're very lightweight, more compact than those big white box things. So going with 33 microfarad tube amp Doctors. They're 105 degree rated. I've never had any issues with them, any of their capacitances or voltage ratings. They've been excellent so far, and let's hope they stay that way. And you might notice that sneaky little V-Shay 1-watt metal film down there. We'll go over that later. And you might also notice those 2.2 megs just mounted to the leg of that 220k grid stopper down there. I've also got rid of the carbon composition heater balance resistors, and I've gone with the 1/2-watt metal film fusible resistors there, 100 ohm. Now some of these components were changed out by the previous tech, some are new. I've left the old ones in wherever the work was adequate. Whoever did it last time knew what they were doing, but I think they were just in denial a bit of how much these amps take to get performing beautifully. Having said that, they were a bit impatient removing a lot of the components. Pretty much all the components they removed, they'd ripped the top pad off. So that's because the factory components had the lead folded over on the bottom side. You can't just pull it up because it just scrapes out like a fish hook as it's coming through the hole, and rips the lining out of the hole from the through-hole plating and rips the top pad off. So the only real reliable way to do it is just cut the components off at the top and then flip the board over, access them from the bottom, and gently remove the remainder of the lead with soldering iron and tweezers. Yeah, I might have noticed a few little sneaky Murata MLCCs, that stands for multi-layer ceramic capacitors in there. I've replaced all the tantalums, they're failure prone. They always come in with shorted tantalums, and replacing them from the bottom of the board is a real asshole. So we've just preemptively changed them. The amp doesn't know any difference, they're just bypass caps on the cathodes there at the preamp stages. And those Muratas, they're rated at 50 volts, believe it or not, that tiny little pebble down there. And they're fantastic, and you can see I've used a bit of Teflon tubing there. The diameter looks a bit silly, it look like oversized pants on the little capacitor down there. But I've got some smaller tubing on the way. That's PTFE tubing, so that's the chemical name for Teflon. That stuff's really good value. I think that's what they use in like the Matchless and Bad Cat amps, and it's something like $10 for 5 meters, and that'll last you for ages. So down here we've got a little Panasonic cap. This cap was actually leaking. It was just a spontaneous failure. Maybe got some moisture in through one of its legs from being bent over. So I've just gone with my favorite Panasonic. Look at the size of it. That is a 630 volt rated cap, and the one next to it's 400 volts rated. So that's a 0.1, but that's a 0.047. So that's the same value as that one. That's a 400 volt and that's a 630 volt, believe it or not. And again, just gone with the Teflon jacket there, just to prevent it rubbing through to the ground planes underneath. For the 22 mic ones, you probably can get the MLCCs in that, but the package starts to get a bit large, so I've just gone back to the axial electrolytics because they're still available in Vichy there. And there's a 4.7 there too. But you could, I believe the MLCCs are available in such large values, so if you were manufacturing an amp, it'd just be another little component that you could avoid using a electrolytic for, given their limited lifespan. Now these two caps, they're the phase inverter output coupling caps. They tend to fail on these and pretty much all Messer amps quite commonly because they're 400 volt rated. When you've got the negative voltage on the grids, the bias supply, and then you've got the positive voltage on the PI on the other end of the cap there on the phase inverter plates. It's approaching the 400 volts, then you throw the signal on top of that and they tend to fail. So again, we've upgraded them to a 630 volt Panasonic. Look at the tiny little things, how compact they are, and perform beautifully. And down here for the low voltage supply, or lowish voltage supply, 220 microfarad. I believe the original cap was 63 volts. All I had in stock was 100 volts, so I've just popped one of them in. The lead spacing worked out alright. And our main filter cap, I say main, but they are all 33 microfarad. We've got our screen dropper there, which I might play with the value of. Might look at what the screen voltage is on these and maybe do a Xena screen dropping mod as well, just to extend the life of the EL84s, because they do have it pretty tough in this amp. Bias feed resistors down there, 330k. They were installed by the previous tech, and there's no reason to replace them. They're still in spec. And down there you can see where I've put a turret. I've just had to cut away at that trace a bit because there was a trace on the other side of the turret on the opposite side of the board. So yeah, real pain in the ass trying to fit a turret in these boards. Because once again, all those traces were ripped up and burned. All the pads and the through-hole plating was gone, so there was no mechanical support if we were to just try and solder that. You would have to fold the leads over to a nearby component, and there was nothing nearby, so it was made more sense to put some turrets in and run some solid core wire with some Teflon jacketing on the other side of the board to recreate those traces. Alright, so I think I replaced the diode there just because its leads were corroded, and I re-terminated all these wires because they were frayed and hanging on by a strand or two, so I re-terminated them and put them as far down, like the jackets, as close to the board as possible to offer them some mechanical support there. Alright, so I'll get this board back in, just do some initial testing, and then we'll run through the stuff on the other side and do some sound samples, blah blah blah, you know, the usual gig. On a side note, Fender Tone Master. Did manage to fix one of these. Didn't think it was possible, but one of the diodes there on a, I think it's a 3.3 volt supply on the motherboard went short circuit. Possibly because of some leaky, you guessed it, tantalums again. So I'll do some more investigation in that, but having brought one back to life does inspire a little bit of confidence that despite not having a schematic for what is essentially a computer, there may be some maybe Hail Mary options out there if yours fails. So anyway, stay posted on that one. Look at that. That's what's providing all your tone for a Fender Tone Master. It looks like a mobile phone. Makes the guts of this Roland JV35 look remarkably old school when you look at the new stuff. And of course I dropped one of the pot washers on the friggin' floor. There you are, you little fucker. Alright, so we had to replace a bunch of these standoffs. They are still available. You can get them from CE Distribution, probably other places too if you spent the time on Mouser to figure out what its code is. Off all the millions of data sheets, you could probably find it for, I don't know, 20 cents less. I just get them from CE personally, but they are still available. So other techs out there, I'm talking to you. There's no reason to put massive bolts and nuts and all sorts of other manners of really weird solutions for a problem that doesn't exist. Just get the right parts, champions. Now there is no doubt about it. No do to boot it, as they say in Canada. Using those little standoffs is quick and easy, and it sure is cheap, but not necessarily something I'd want on my amps. Although, you know, if Messer Boogie can have their team of fanboys and do stuff like that, maybe I can too, and make an extra few bucks an amp. No, I wouldn't do that to you, champions. One that's not available, or I don't know where to find it anyway, is these ones that hold down the stupid clamp thing that goes over the top, and the little hingy ones that are on the other side. And as you can see in part one of the video, they are missing on this one. I don't think there's any real solutions for that. I just leave the bloody thing off. The socket's given enough tension to retain those little EL84s. And failing that, I don't know, I guess we could rig something up, but seeing how deep those valves are down in the sockets, there's nothing that instantly comes to mind that would be easy. But this is a studio amp. Well, yeah, the actual customer's application for this amp is a studio amp. It's called a studio amp, but if you were taking it on the road, I'd probably look further down that route. But when the amp's just sitting there still, it's not as much of a concern. So let's get some valves in this little buddy and flip her over and show you the guts on that side. So just a quick look at the stuff I've done from this side that wasn't visible with the board flipped. I've just put a bit of heat shrink over that braid there, so if any other techs or whatever get in there, or if it just moves around, because it is loose, there's nothing really tying it off. It won't short out to any of those connections down there on the board. For the flimsy little reverb cable, that's the return cable there. I've actually, it might be a bit hard to make out there, but I have put a clear heat shrink over it just to give it a little bit more resilience instead of those wispy hairs floating around in the thing. And I've put some thin heat shrink tubing on the actual jackets there to run them down to the valve socket. Just makes it a bit stiffer, a bit more resilient. I already said that once, didn't I? I need a thesaurus. And the world's weirdest ground clip, I don't know why he did that on all of these, but that might be a handy little spot to put 2 cable ties just to anchor that wire there, keep it away from the mounting screw, and just float it above the board. Oh, hiccups. Excuse me. So there's a little bit of flux there in a few spots where I was tweaking stuff. I'll clean that off before we button her up. Now here's the bottom end of those turrets. A few places I've had to cut the ground plane away a bit to give us adequate clearance, because the turret, you know, needs to flare out a bit bigger than the original pad was. Missing pads there. I've brought some leads up from the components that have at least one good pad, and then formed a hook and wrapped a bit of bus wire around that, passed it up through the turret. Not pretty, but it is functional. Over here I've just tapped into an existing trace, which I don't really like doing, but it's got nothing else going on near it, so that worked okay in that case. Re-terminated the heater windings, you know, pushed them down a bit further, got some fresh wire out of there. There was just enough slack on them to be able to do that. Put some little hooks on the anodes, just to have a handy little spot to clamp onto with the meter, and on the B plus over there, which is the center tap of the output transformer. And again, we've just got rid of some of those burn traces or destroyed traces, and just run a bit of bus wire with some of that Teflon jacketing. Likewise down there, a bit of trace repair where there was significant damage, missing pads, all sorts of horrible stuff down there from a combination of the previous tech and just straight up heat damage. Now down here we've got the low voltage, well, supply, I guess. It supplies the it biases the phase inverter via the cathode, and it also biases the output valves. Now I've got no idea what the goal was behind all of this. Probably just to get another patent. We all know Randall was a patent troll. Someone piped up the other day asking how many patents I have, and I replied I don't have any interest in patenting pre-existing technology, because that's a bit of a dog move in my opinion. I mean, you got a master volume patent. There was pre-existing technology for fucking decades before he got that patent for a master volume. Anyway, I digress. There's a whole story behind that. I don't want to get into. It's history. We can just forget about it now. Forget about it. But point being, I put those resistors up on the top side of the board so I can take some measurements and tweak them if required and fine-tune those voltages. But we'll be fine-tuning the screen grid voltage and the bias voltage via some other means as well. There are many layers to these onions. Some of those faults result in noise, as we demonstrated with that mixed resistor thing pulled from a Fender circuit, and some of them manifest themselves as the output stage being biased not where expected. Instability, you pull a phase inverter, your bias free output valve goes out, you change valve type. It's just, there's so many. These things are a little bit twitchy with the way they're designed. So, but once they're set up, they can sound like a boxy, weird overdrive amp, but when you put an EQ pedal in the effects loop, you can sort of approach the Mark II, Mark III series sort of sound, which is what the kids want these days, you know, 1983. So other techs will know, particularly Mesa Boogie techs, as soon as you put the hardware on the pots or the knobs on, it's sort of bad luck. Like, you're definitely going to have to take them back off again to address another problem that you could not have foreseen. So we try to leave as much hardware as possible off until at least initial testing. It's sort of like you don't put the knobs back on until you know everything's right. It's a bit like saying, don't say good luck to someone who's about to go on Broadway, you say break a leg. But in this case, the pots are just, we've got some bus wire there, but the pots are kind of free spinning, so you need to tighten them up a bit just to stop them from doing that, because they're not circuit board mounted. Well, right, champions, we fired it up quickly with the very hack, and then I gave it full voltage once I was happy that there was no catastrophic stuff going on. And we're sitting at around 98% bias there, so about just under 12 watts for the, well, per EL84. So that's not great for a fixed bias amp. I don't mean to sound like a broken record, but a lot of these manufacturers seem to not know the difference between the bias points, whether it's cathode biased or fixed bias. So a lot of them will run it at 100% on fixed bias and like 55% at cathode bias. I'm looking at you, Marshall. So we'll tweak the screen supply with the Xenon mod to limit the voltage. At the moment we're sitting around 320 volts on the screens. We'll see if we can pull that back a bit. That will bring it down a touch, but it won't bring it down enough. So we're going to have to dive in and play a little bit with the voltage divider seesaw bloody arrangement, which is what I was afraid of. But because I was afraid of it, I put the components on this side so we can easily adjust them. Up here for thinking, down there for dancing, champions, as Michelle says. Don't ask. Alright, champions, so we could have gone nuclear option on this and gone with the full solid state relay modifications and all of that, but we're sort of running out of time and budget on this one, and it's a bit more difficult to implement in the Studio 22 as opposed to the dual caliber that's sort of got two independent channels. So I've just done some more tweaking to the values in that sort of input mix resistor arrangement. I've changed the capacitance and resistance to try and get the noise down a little bit less hiss, but not affect the tone too much. And we've played a little bit with the values in that divider down there, very minorly, but that's brought the dissipation down to about 60%. So that's fantastic. Let's get this thing back together and have a quick listen. One day if one of these pops up cheap, second-hand, I might delve a bit deeper into it, because there are quite a few around, but they're definitely not the most common amp out here, but probably get one or two of them a year, that kind of thing. So it's sort of cost-benefit analysis of, do you put the inertia into like a full-on project on making these things sound fantastic, or do you just get them as good as you can with the existing infrastructure? And we've gone with that in this case, because it's pretty time-consuming giving it the whole works burger for a amp that only goes for about $1,200, $1,500 second-hand. So anyway, let's get this thing back in the cabinet and have a listen. But before I put it back in the cabinet, I've just given it a good clean, good scrub. You should have seen the dirt that came off this thing. The bucket was, the water looked just like dirt. I have put some new, the original foil had gone a bit crackly and sort of flaky, so I just laid over it with some new foil and make sure none flakes off. Make sure we don't rip it when we put it back in, so it'll give some better shielding than it had before. They had a like a adhesive aluminium foil, but they'd spray painted over it, so I don't know how effective that even was anyway, if it was making good contact or not. And it was quite ripped up around the areas where you fix it off. Alright, so now I've started playing it in the combo. One of the preamp valves has decided to go microphonic. Of course, because I just sent the invoice that didn't include one, so... You've literally heard it happen right as I started. Now it's really sensitive, so we're going to have to change that valve out, find out which one it is. That'll probably take off by itself if you turn the volume up. Always the way, we get all dressed up. So let's find out which one it is and change it out. Alright, so I've left the valve retainer off because it's shit anyway. Alright, we're back. Swapped some valves around and replaced the V1, whatever the parallel triode one is, with Tube Amp Doctor 12AX7WAR, which is reasonably quiet in that position now, and the microphonics are still there but reasonable. High gain amps, they're always going to have some degree of microphonics. It's just a matter of if it's acceptable or not. So where were we? I knew this amp wouldn't be happy until it fucked up my camera angle, so let's start again, pick up where we left off. Alright, now let's see how we can make this thing chug, obviously with the EQ pedal in the effects loop, because without it, it just sounds like it's coming through a radio. I think with my initial experience with Messrs, that's what I just couldn't get my head around, the fact that they need equalization after the distortion stage, because they just sound like a honky, boxy radio pile of shit without it. So if you have one without the EQ, I highly suggest just getting just any brand graphic equalizer. This one's a good one, Maxon, made in Japan. You can find these on my website to simulate the EQ that would normally be there, and it really makes it a lot more usable. Alright, so there's a lot of contention on how to dial in a Messer. Basically, your EQ is before the distortion stage, unlike a Marshall. So, well, distortion stages, I should say. It's a cascading effect. So, if you EQ these, you got to think about what you're feeding to the overdrive. So, you want to suck the bass out of it. I find that if you push a treble too far, it gets kind of shrill, almost sounding like a fuzz pedal or a Fender really pushed way too hard, because that's basically what these things started out as, modified Princetons, and a healthy amount of mids. So let's try that, because what happens is distortion brings in subharmonics as well as harmonics. So it brings in more treble, obviously, but it also brings in well, it brings in subharmonics as well. So it does create bass, essentially, where there wasn't any previously. From the this whole book's written on this stuff. I'll put a link to one in the description below. I still haven't read the whole thing. Alright, so I'll dial in the treble around 6 or 7, bass around 2. I'll just show you what the EQ does before it. To start with, we'll start with the EQ off, and mind your ears. Alright, so that's a lot of gain, and the volume's on 2. So let's push it up. you go, legends. One of these with an EQ pedal in the loop does turn it into a bit of a metal beast, which is pretty fantastic. And the clean channel, we've cut back the hiss quite a bit. It's still very much present, but it's very much usable too at stage volumes in particular, but you could still get around the signal to noise ratio in the studio as well. And so basically one of these requires quite a bit of work to make it reliable, for starters, not burning EL84s every 6 months. And if you wanted to go all out, you could make it a real quiet clean channel, but there would be some pretty heavy modifications required to do that, and didn't really want to go down that road on this one. But one day I might, if I find one cheap, maybe have a look at it. But how good do you want to make it sound? Well, it's still got the Boogie label on it, you know. Anyway, I am softening to the Boogies a little bit. The messes, some models anyway. Now that the company's sort of, I don't know, what is it now? Is it really even a company? It's just been swallowed up by Gibson, so, you know, it's kind of a historical thing now. Everyone can have their opinions on them, but it is what it is. It's sort of, it's done. People do love them, and they do have potential to be fantastic amplifiers. But you just got to do a bit of work to them, champions. Anyway, I'm rambling, so I'm going to piss off. I'll see you on the next one. Oh, I meant to mention, thumb right up there for me, would ya? Check my prostate while you're there. And I'm going to go. I always do this at the end of the video, so just start rambling, and then I start talking about things, and then, you know, I start just going around in circles, and then I don't know what to say, and